So, very good afternoon to you all. Myself Mayank, and I am gonna presenting my video PPT on the topic of transforming space signals, the astronomical impact of Fourier analysis. So, we will understand about this topic in further slides. So, let's begin. So, in this presentation, we will understand how the Fourier transform or how the Fourier analysis will help to analyze the astronomical signals or the astronomical phenomena. So, we will understand what kind of astronomical signals are there. So, there are three subdivisions of those signals. First is radio waves, second is visible light, third is X-rays and gamma radiations. So we know already that what is radio waves from pulsars and supernova or supernova remnants, or we can say the big astronomical phenomena which causes to the cosmic microwave background to emit these radiations. So the second is visible light. This is the light we see from stars, galaxies, and the other celestial objects. In last, there is a like X-rays and gamma radiations, which emitted from very high energy events, such as like the black holes and active galactic nuclei. So, by before moving forward, we there is a very important to understand this that concept behind the Fourier series and Fourier transform. So there are four subdivisions to understand Fourier transform. Like first is Fourier series. What is Fourier series? Basically, it is a method to represent the periodic signals as a sum of the sine and cosine function. So the periodic signal first, so like we already know from the lecture which is going on this semester that the periodic signal, any signal in the universe, is not a complete periodic signal or a pure periodic signal because of that error, because of any kind of error. No signal is periodic. So but here we are taking an assumption. So to understand the Fourier series, so that if the Fourier series is a method that represent periodic signal as a sum of sine and cosine function, and then the Fourier transform. This extends the concept to non-periodic signals, which break down into their respected frequency components. In third, there is a frequency domain, which is the Fourier transform that allows us to analyze those signals in that particular frequency domain that can reveal the hidden patterns and informations. In last, it is inverse Fourier transform, which reconstructs the original signal from its frequency components, which enable us to understand the like synthesize that signals that we want to understand. So now we are ready to move further to understand the application of Fourier analysis in the field of astronomy. So what is the process in general process? First is spectral analysis. So in spectral analysis, we decipher the composition and properties of the celestial objects and stars, and then we map the distribution of radio sources, that what kind of radio sources are there, and to understand the structure of the universe. So after understanding those structure of the universe, using that radio astronomy, we analyze the gravitational waves and different kind of waves, or like first we have to understand what is gravitational wave. So like uh, we will understand this in further slides. So we, after analyzing those gravitational waves, we extract the information about that particular source that we want to study. Then after that, we analyze those signals to generate the astronomical images to reveal the hidden details and features. This is just a table which we show that these are the spectral lines and this is the element, respected element. So hydrogen alpha belongs to the element hydrogen, and the spectral line of calcium K belongs to the calcium, and the spectral line of sodium D belongs to the element sodium. This is a sequence of Fourier techniques, like very important Fourier techniques in radio astronomy. So the first technique is going to be interferometry, which is a very famous technique, and then signal correlation, and third is image reconstruction. So in interferometry, we combine the different signals that coming from the multiple telescope. So there are like we know that we have a lot of telescope in the ground stations. So that there are the different signals that comes from multiple telescope. So we combine those different signal to achieve the higher resolution. So after understanding those, after analyzing those signals, we use some Fourier techniques to correlate those signal from multiple telescopes. Using that Fourier techniques, it is very easy to correlate those signals from multiple telescopes. In last, it is image reconstructions. So after getting those, after combining those correlated signals coming from the respected different telescopes, that initially that comes from the different sources in the celestial objects. So after correlating those signals, we generate detailed images of those celestial objects by combining those correlated signal. So we can understand that how these three methods, some methods, combine itself to give us that what fascinating things, what fascinating images we are getting in the internet. Those images comes from by using this Fourier techniques and this phenomena. So these three steps combine together to get this kind of beautiful images. So we can in childhood we used to get very amazed to see those kind of beautiful images, and at the time we don't, me myself, we don't we don't have that reason behind those generation of those beautiful images. So now we can understand in these three sub processes we can finally construct those image with that correspond to the respected incoming light, that can be a gamma radiation, or that can be radio waves, or that can be the gravitational waves. So we can understand what kind of image that can be by using this Fourier techniques in the field of radio astronomy. So we can understand those gravitational detection and Fourier analysis. So like what is gravitational waves? So with this just according to the physics, those in this universe, that mass which having everything which has the mass that has its own gravitational field. So that gravitational field causes the gravitational waves. So this gravitational field uh, makes some kind of ripples in space-time that caused by its massive events. Like we know already that there are lots of massive events which is going on in the field of astronomy in outer space each second, or each time. So like in a particular star or a particular celestial object, it cannot remain stay forever. It can cause some massive events starting from their creation to extinction. So these massive events such as black hole, these events causes the space-time to get ripples onto it. So this causes the gravitational waves. And this second thing was interferometers. So these instruments used to detect the gravitational waves just by measuring tiny changes in distance between mirrors. And then finally, the Fourier analysis that used to filter out noise and extract the signal of gravitational waves from interferometer data. So yeah, I told earlier that there is we have to deal with noise or that, because that noise can causes a lot of error, which from by which we can face very lot of difficulties to extract the images, to generate those images. So Fourier analysis is very important, that for filtering out those noises and extract, and that we can extract the signal of gravitational waves from after that from interferometer data. Now it is the Fourier based image processing in astronomy. So then what we do, like first is image enhancement. So this is Fourier based image processing. So reducing noise, sharpening edges, and improving contrast in astronomical images. And second is the feature extraction. So we can identify and analyze those specific features in images such as galaxies, stars, and nebula. So using this method of field feature extraction, which is based on Fourier-based image processing, we identify and analyze the specific features in images that we got captured. And in third, image restoration. So in image restoration, we remove those distortions or some ups and down caused by the atmosphere or telescope optics. So in this way, we we finally got the beautiful image of those image of the celestial objects that we can see on internet. Now here is the mathematical formulations and equation. So here it is just equation which from which we can see that how the Fourier transform actually works in mathematical concept. Here, so that's all about the presentation. So now we can understand here that how we use the Fourier analysis to understand the astronomical phenomena to grab some beautiful images of those celestial objects by using the Fourier analysis. So thank you.